Hello everyone, this is Grace. It is November the 19th, 2021, and today we're going to be taking a look at the seasons. And I am going to make a few comments about the red moon as well. Unfortunately, I thought that the red moon was tonight. I thought it was the night of the 19th, not the night of the 18th after midnight. So I did not see it, unfortunately. However, I did think about it, and it doesn't really fit um, the original theory that I gave you. So I had to do a reassessment of what I originally taught. So I now believe that, and I don't have graphics for this, I'll just have to explain it to you, unfortunately. I now believe that rather than the sun hitting the moon directly and causing the damage that leads to the red moon, I now believe that there is a black moon in between them. Because if the sun were hitting the moon directly, then you could not have a partial red moon. It would be illogical. However, if there was it actually works out better. If there is a black moon in between them, magnifying the rays of the sun, that would cause the slight damage to the moon. Also, it would only magnify the area which was covered by the black moon. Thereby, you would be able to have a partial red moon. And it's much more logical if the rays of the sun are magnified than if they're just close to the moon to cause damage, because it's very difficult. It's very, very difficult just to melt CO2. So the idea that the sun would be able to melt to cause damage to the moon by itself, it makes a lot more sense if that light is magnified by the black moon. And if you haven't seen those videos, I'll attach it at the end. That explains what the black moon is. It's the eclipse video. You'll want to watch the video on the eclipse and what causes it. So anyway, I had to adjust that. I had to tweak it a little bit, but I actually think it works out better, and it does. And you can have a partial red moon under this new definition. Okay, that said, I really wanted to talk to you about the seasons, but it's gonna lead into discussion about the lunar eclipse as well, because of the way they say the light reflects off of the moon to cause the lunar eclipse. So before we get into that, I want to give you an explanation of the different kinds of light. So you have there's two different kinds of light. You have point source lighting, which casts the light outward in one direction from a single point. And what that means is you have the sun, and if you recall when you were a little kid and you would draw the sun, you would have, hold on. It's this recording application that slows up my computer so much. I figured it out because it's never slow until I turn on the recording device. So you would have the sun, and you would draw all of these waves going out like that, and there would be curly waves. Oh, this drives me crazy. And they would all be going out from the sun. Of course, the sun is not round, it's a disc, but assuming that it was, they all go out in one direction. That's point source lighting. Extended source lighting is really everything that is not point source lighting. But the way you can tell the difference is, hold on. Okay, hold on. The way you can tell the difference is you'll have just one shadow. And think about it, it makes sense. If you have light coming from one direction, then you're going to have one shadow pointed in one direction. That's the sun. You always have one shadow, and it's a dark shadow. It's called a penumbra. However, if you have light coming from more than one direction, then you're going to have more than one shadow. It's going to cast what's called a penumbra, and that's the second lighting here. So this is a cheap flashlight. If you have a cheap flashlight, you're going to have a light in the middle that's going to send light going forward. That's one direction. And here you have your penumbra shadow, which is going to be the darkest part. But there's also going to be reflectors in the back of this light. And it's going to reflect light going downward, and it's going to reflect light going upward, and it causes a second shadow to be created. That's the penumbra. If it's an expensive flashlight and it has a lot more power going behind it, it won't cast the second shadow. It'll all get absorbed into one light. It'll cast one shadow just like the sun. But it has to be an expensive flashlight. Again, point source lighting. This is your sun. And it's hard pressed to find anyone to tell you that the sun is point source lighting, because it goes against what they teach as far as the eclipses are concerned, which I'm going to show you that in a moment. I found one person, I think, that said it. And when he said it was because the sun is so far away. That's not correct. That's not correct. If you remember, if you're old enough, you remember when you had those old video games that were black and white, and you would walk around, maybe you take them to the park and you play them. If you played them on a sunny day and they were black and white, you would have to go find some shade to hide the screen in, because the light would just get sucked up by the sun and absorbed, because the light from the sun is so powerful. So the rays of light that came off of your machine, you couldn't see anything. You would have to go find some shade away from the sunlight in order to see the rays that came off of the machine. And it's not really that the sun is so far away that causes it to be a point source lighting. It's because it's so powerful, it just absorbs anything else that comes in its path. And it casts one shadow. And you saw that if you saw the first video I did, where I referred you to this guy who did light experiments. The one experiment that they left up was where he held a black and white phone up to a more powerful light, and it looked like the screen was black because the light just got absorbed by the more powerful light. That's similar to the way the sun works. Fluorescent lights are a little bit different. Now you can get an extended light source from many different sources, but there's something about these fluorescent lights to where even if it's just a small tiny light where you might think it's a point source light. For instance, if you get a regular light, you can take a piece of paper and you can put, well, even a fluorescent light. If you have a cheap flashlight, you can put a piece of paper over it and poke a hole in it, and then it becomes point source lighting. All of the light will extend from that one point. But I remember when I was like back into the health craze phase, natural health things, they said there was something different about fluorescent lights. They used to say it had bad karma. Something about the way it casts light off. I don't remember. But anyway, it's not uncommon to see fluorescent light used as an extended light source, because you'll have light coming from this end and you'll have light coming from that end, and a lot of times there's just 2 or 3 lights under that one fluorescent bulb. Here you have light going straight ahead, you have light being cast from this end and it's going diagonal here, and it casts a shadow up here. You have light being cast from that end and it's going diagonal, and you have a shadow going in that direction. That's the same logic that they use for the red moon as well as the eclipse. They want you, here, I have a better picture than this. They want you to believe that the sun casts light coming from here to going straight across, from here going up, casting another shadow, and from here going down, casting another shadow to highlight the moon and make a red moon. It's just not true. The sun is a point source light. It has one light. It casts one shadow. That's all it does. And in their own logic, that has to be true. I'll tell you what has to be true. I think I wrote it down, but we'll just jump to it and I'll show you here. Let's just say, according to their logic here, you have this one source of light that heads straight out, right? And it hits this one point at a 90-degree angle. Well, on a circle, there are no 90-degree angles, first of all. Okay, so that's already wrong. Everything is at the exact same angle. But we're going to say, we're just going to play along for a moment. So it hits this one point at a 90-degree angle, and that's supposed to be so intense that it heats up everything upwards, but only 23 degrees, no further, and everything downwards for the 66 and something degrees that are left. We'll say 65 degrees. So it causes all of this to be summer because it hits this one point, and as the earth rotates around, it goes around and it heats up the earth, right? But it only goes 23 degrees up, but it'll heat all of this 65, 66 degrees down. And everything up here just freezes for no reason. No explanation whatsoever for that. But it doesn't go 65 degrees up, only down. So let's just say this is true. It's illogical, but let's just say it's true. If you have a point up here that is going down, then you have a whole new point which is being highlighted. If this is a different ray which hits the earth, now you have to contend with this angle, which is going to also heat up the earth. If you have another point coming from up here, now you have to contend with all of this being highlighted as well. This still has to be heated up from this one single point that's going up. The whole world becomes hot. And all of it has to be hot. If there were rays that were shooting upward and there was rays shooting downward. I mean, according to their logic, we believe that the sun casts one ray across the earth. Well, we don't believe that because the sun is not round, it's a disc. We don't believe that. But that's what they want to teach when they teach the seasons. They teach that these rays are not actual. There's different forms of light, and they will usually show you what they call a line of light, which is they'll show you a flashlight, and they'll show you the flashlight hitting a desk or something at a 90-degree angle, so you can see the white hot area, the highlighted area, which turns white from being directly hit by the light. And then they'll bend that light sideways so that it appears to bend the light. It doesn't really bend the light. It's just that different parts are further away. So it really does hit it at a different angle. But see, that's part of the calculation for light, for the intensity of light. We'll jump down here. We are told that distance is either not a factor or not the primary factor for seasons. That's true. They say, well, if distance was a factor, then everything would be hot because everything here is hit by the sun at the exact same time. So everything would be hot. And then as it rotates, it would be hot, it would be hot, it would be hot, right? So they say distance can't be a factor. Everything would either be hot or it would be cold. So they say it's not a primary factor, or either it's not a factor at all. They're never clear for the seasons. They say the intensity caused by the angle of the light is what is the primary factor. However, distance is used to calculate the intensity of light. Whereas angle is not used as a factor in this calculation. The intensity of light equals the power divided by 4 times pi times r squared, where r equals the distance. They have little measures on all of these meteorologist stations, right? They have little measures on all of them that measures the intensity of light. And it's at 0 when the sun is down. And as the sun comes up, it increases in intensity and increases in intensity until noon. And then at noon, it's at its height, and then it begins to go down until the sun goes down and it's at 0 again. And distance is a factor when measuring intensity. And yet they tell you the intensity is measured by the angle. It's just not true. Let's read through this real quick and see if there's anything that I left out. I'm trying not to make real long videos on this. So, the Earth is a point source light. However, it is treated as though it is an extended source light when calculating the red moon. This is incorrect, as sunlight hits the Earth at the exact same angle because it hits it in singular points, not lines. Exactly. There's no such thing as a line. Well, there is scientifically. Let me make sure I looked at all of the... I did. We looked at all of the graphics. Okay. But it's just, I mean, it's light. It's not a physical thing where you can bend and manipulate it. It's just, it's light. So it's going to hit it at the point that it hits it. That's why I was more than willing to give them that 90-degree angle. It's just going to, because it's just going to hit it at whatever point it hits it. It just is. The problem is that it's not just going to be real picky about this 190-degree angle and give it light and not give anything else light. That's the problem. Okay, I know that probably didn't make a lot of sense, but just forget it. Never mind. We'll move on. Point source lighting casts light outward in one direction from a single point. It casts only one shadow. It also casts only a penumbra. It does not have a penumbra, which is a second shadow. The sun is therefore point source lighting. Extended source lighting is light which comes from more than one direction. It casts more than one shadow. We are told sunlight hits the Earth at a 90-degree angle, causing that area and its surrounding area to have summer weather. However, there are no 90-degree angles on a circle. There just isn't. If light is cast from more than one direction, it directly contradicts their premise that the seasons result in exactly one point of the Earth being hit at a 90-degree angle, as each light source would cast a ray of light at a different angle, resulting in several hot points. If the 90-degree angle is the catalyst for warm weather, why are there no summer conditions during spring and fall? The 90-degree point is still there, yet neither hemisphere has summer weather. And I'll point that out real quick and then we'll close out. So what I was saying is that they say that the sun hits the area here at a 90-degree angle. Well, the 90-degree angle supposedly, it's fictitiously, is still there when the Earth moves over here. It's still going to hit it at that same angle. The only difference is they say, well, we're going to change the weather to spring and fall as opposed to summer and winter. Why? Oh, wait, because part of this is hidden up here. They do say this part right here, it doesn't get any sun. So there's winter here, but everything else that gets sun is winter up here as well. And everything down here is summer. Where you have, according to them, 12 hours sun and 12 hours 12 hours night. You have a whole lot of sun here and no summer weather. It's illogical. It's illogical. It's logical. Anyway, that's all that I have for this video. There were some other things that I pointed out, but that I found, which I'll do a separate video for. I didn't really want to make this too long. So I'll leave it at that, and I will see you in the next video.